This conference will now be recorded.
Welcome everyone to the demonstration 2 on cloud performance engineering in DevOps. Yesterday we did introduce this slide, but we could not get we could not discuss more on this. We wanted to cover the course syllabus yesterday. Just to take the brief of the yesterday session, uh, if you're looking for this is the link that if you're looking for the more information about the course syllabus, if anyone missed to understand the course syllabus, they can go over the recorded session yesterday, or they can go over this link. Okay, so coming back to our discussion, so yesterday we introduced this slide on the software development and deployment evolution, and we understood that as per the current trend, we need to understand a cloud in any cloud service provider, public cloud service provider like AWS, Azure, and Google Cloud. They are the three most popular market leaders in the cloud industry right now. And if we know one, it's easy to understand, easy to get hold of other cloud service providers. Microservices, because when we started with the software development, we started with this monolithic architecture, and now and it has a lot more disadvantages than advantages. And now we are trying to migrate from monolithic to microservices. We're trying to break down our application from monolithic to microservices architecture. And then to run this microservices, we need a runtime environment, and that is called containers. Okay, and then that's what we talked about, containers. And then for these containers to run, we need a Docker, a container engine, basically, to create containers. Like suppose to create VMs, we needed the virtualization software. If we do not install the virtualization software, we cannot create VMs on the physical servers if we have. Okay, the same thing for the containers as well. So we need a container engine to create containers, and then the DevOps. We started with waterfall. We are still, most of the company are still using agile, but this DevOps is the trend now where we want everything automated. That this automation is what we are moving towards, and we need to always keep in mind that we need to know ways how can we automate stuff, and that will add value in our day-to-day life. So using Jenkins, we can DevOps, we can use the we can automate the CI/CD pipeline. That's what we will learn in this course. And if we have more containers, how can we schedule all those containers for auto scaling, load balancing? And for that, we need a container orchestration engine that is called Kubernetes. We'll be talking about that. And the cloud is the best example of automation. They have automated everything. We can leverage any resource remotely. So that's what the cloud means. So we'll just go brief about these topics today, and then we'll dive into each of these things in upcoming sessions. Okay. So let's touch base with DevOps first. So when I say DevOps, so basically what does it mean? So basically, if you see this is an infinity symbol, DevOps, if you see this, so it's a continuous process. It starts with plan and code module, this plan and code, where the softwares are getting planned, and then we write code, and then we build the software. Okay, we plan the software, we write the code, we build the software, and to build the code, we need some software to do that. So that this comes under a continuous development. Okay, so this entire DevOps life cycle is divided into 5 phases. That's called DevOps life cycle. So what is a DevOps? It's a software development methodology, like what we have waterfall, then we have agile, and now we're talking about DevOps. So it's a software development methodology which improves the collaboration between the developers. So here we have the developers, and then we have the operations team. So DevOps is made of two words here, development and operations, and dev and ops. So they have taken one word from a part of the word from the development and a part of the word from operations, and they call it DevOps. So when we have plan, code, and build, so that's called the continuous development phase. And what the developer do, they write the code and they have a central repository like GitHub or Bitbucket, anything it could be. We'll be taking example of GitHub here in our example. So we will push some code to the GitHub, and automatically what it should do, it should trigger my build code, build a job. We'll create jobs in Jenkins, and it will trigger my build job. So automatically my code will be built. So my code will be built means it will run and it will make sure that build is successful. Then only I can deploy my code, right? And then second comes the testing phase. So once this is built, the code is built, it gets deployed to the testing environment. Okay. Then and then we do testing. It is, and testing is could be of various types. We can do functional testing, uh, so that like functional automation team would be writing Selenium scripts. Mostly we are using here open sources tool. So we talk about Selenium and Jmeter here. So if you have a functional automation QA team, they would have Selenium scripts to validate the application. So the Selenium job would get triggered, and then it will check for the application functionality. Then our it will further, next stage would be our performance team. So our Jmeter job would get triggered and will check for the application performance. So once that is done, now it's time to release the application. So it is a continuous integration phase that we call it. So this is testing phase. We have continuous testing, and then we have this release phase here. We call it continuous integration because it will integrate, because we need to now push this code to production, right? We need to deploy this code to production. And that's what we call it, continuous integration and the continuous deployment phase. And then it will, once the code is deployed to the production, it will be continuously monitored and the feedback would be given to the development team again. And this cycle goes on. This cycle goes on. And that's what we mean by this DevOps. So it smoothens the process. So what all developer did, it just developer just checks in the code. That's it. That's the only manual activity that has to be done, whether it fixes the bug or it has changed some functionality or it has added some module. The developer checks in the code. That's it. That's the only thing, and it will trigger the jobs next to it automatically. The build job would get triggered, my code will be built, my testing jobs would be triggered, it will be functional, my all the functional testing suite will run. It will be after the successful confirmation of the testing results, it will be released to production, it will be deployed to production, and then the continuous monitoring will be done, and then feedback would be given back to the development team. And this cycle goes on. So that's the brief about the DevOps. And we're going to talk about Jenkins here, and we'll talk about the performance job here. How do we create jobs? But we'll understand the entire life cycle here. We'll talk about GitHub here. We'll create a repository in GitHub, and we'll push some code, and we'll understand and that how the code will be built. And then if it builds, we'll take this Docker example here, because Docker goes hand in hand with DevOps. Because uh, if someone is new to that, so don't worry, we'll cover that slowly. Okay, so first we have container engine, and then we talk of DevOps at the end. Okay, so we use Docker here to, so that we get the environment, a builder for the testing environment, and then we schedule jobs here. We'll be scheduling, creating performance job here, and upon successful criteria of performance job, and we'll be demonstrating using Jmeter script here and Jenkins. Upon the successful criteria of the performance job, your job would be pushed to production, and then this cycle goes on. And it really smoothens the process. It can be, software can be released in no time, Everything is automated here, no manual intervention at all. That's it, and that's the DevOps for you. Okay, coming to the microservices now. So, so I'm just going to touch base on these topics one by one, and then I'm going to deep dive on my first thing that on the regular sessions we take the cloud here. We start with AWS. So I'm just going to touch base on each of these topics first. That's the plan, okay, for today. And then if we have time, we'll start with our main regular course syllabus. That's AWS. We'll create account and then we'll get started slowly. How do we proceed and things like that. Okay. So let's go over. So we have covered DevOps here. I'm going to cover microservices, then containers, and then something about the cloud. Okay, so that will be the roadmap for this session, the scope for this session for today. Okay, so let's come into the microservices. So first of all, what is this microservices? So first, to understand this microservices, we need to understand the monolithic application. Uh, Monolithic application, when I say, I mean like the softwares are tightly coupled. When I say tightly coupled, so just consider this example here, this particular one I am highlighting here, this particular diagram. Here, let's suppose I have a bookstore app. Okay, it's the one application. It could be any app. I have suppose 4 modules here for the bookstore app. I have accounts, shipping, payments, and inventory. And I'm writing few functions here. These are the different modules. And I'm talking about the business logic here. Okay, the application server, whatever application, the code we host on the application server, the business logic. I'm not talking about the web server and the database server here. I'm talking about the application server, the business logic here. So my code is written for the accounts, shipping, and inventory and payments module. Suppose I have few functions being written here, account section F1 to F10. And then for shipping, I have few functions being written, and for the payments and inventory, same thing. So the point is that I can call the function of the accounts module in shipping or in payment or inventory. I am free to call any function anywhere. Okay, and that's when I call it's tightly coupled. The code is tightly coupled, and if they are hosted on the same application server, obviously the code is tightly coupled. So the problem is with that, suppose if accounts goes down for any region, suppose this account is not working, and I have been using the code which I'm writing for the accounts module in other modules as well. There could be there's a great chance that my other modules can get impacted if I have an issue with one of the modules. So to sum it up, I mean to say, for any one small issue in any of the modules, my entire application can go down in the case of monolithic applications. And, and there are some other disadvantages as well. Suppose I started with this accounts module, uh, and I have selected one Java language to start writing the code in this Java or Node.js language. So for the upcoming modules, I don't have any option to go with any other technology or any other or any other language. I have to stick to the same initial decision, what I have decided in the case of monolithic applications. Okay. And that's again one of the disadvantages here. Scalability is again a problem. Suppose there is a functionality, something like payment, shipping, or there is, suppose this shipping needs more resource, so there are more user hits on the shipping module. Okay, and I would like to just increase the capacity, the resource for the shipping module. I cannot do that. I have to increase the entire application stack. I have to increase the application server resource itself. I cannot do I cannot increase the capacity of the shipping module itself. Okay, so there are the few disadvantages of this monolithic application, and that's where we come to this microservice architecture. So the monolithic architecture biggest disadvantage here. So it's a three-tier application. Okay, it's a monolithic architecture. It's a three-tier application that we usually have in our organization. your web server, your application server, and DB server, and all the code resides in the business layer. And that's what I'm talking here, that it's tightly coupled, code is tightly coupled. I am calling the function which I'm writing in the accounts module anywhere in any other modules as well. So there is a huge compromise on the redundancy. So if one of the modules goes down, my application may go down completely. That's the case. So that's the reason I'm trying to solve this problem. And in the course of solving this problem, what I can do, I can break down this. I can make this independent, these modules independent. I do not want the code to be reused anywhere. Accounts should have enough code and it should run on its own. So same thing for shipping, payments, and inventory. And you can just check this diagram here. I have made this independent here. So it's loosely coupled here. Okay, the modules are loosely coupled, and I have divided this into microservices. So now each modules will be my different microservices. Okay, and there is no code dependency. So whatever the code I'm writing for the accounts module, I am not going to use the functions anywhere else. Okay, that's what I'm trying to do. I'm trying to make each of the modules independent, so that even if one of the module goes down, others module are still active and still functional. It should not impact my other modules. So that's the brief definition about the microservices architecture. We're going to talk about more in our regular sessions. So that's just a brief introduction here. And you can just see in this architecture diagram that I'm breaking up my business layer into various microservices. That's what I'm doing here. So for this example, I have broken down these four modules separately so that there is no dependency on each of these modules. Each module is independent, specialized, and autonomous. So that's the characteristic of the microservices architecture, and it gives a huge benefit on the resiliency. It will be highly available. My application will be highly available. So if any of the modules goes down, it will not impact the other modules. Okay, and it will also, and I'm also used to use different technology freedom. I can use different languages as well. Suppose for the accounts, I am using Java, but for payments, I can use different language, Node.js. For shipping, I can use Golang. So I am free to select my technology and language for the upcoming, for the new, any other microservices as well. So that gives me a freedom. So I can optimize my different modules in a way that I want. I can customize that, and as per the best performance requirement, I can use the technology and the language for different microservices. But this was not the case with monolithic applications. I had to stick to the same technology, same language that I have started with. Okay, so that's the difference between a brief difference between a monolithic and microservices architecture. Okay, and the next question comes, and the advantage, there are huge advantages of microservices here. Flexible scaling. I can scale up the resource of any one microservice if I need. If I am observing that my shipping module is getting more user hits, it has more user, like suppose it has more load, and what I can do, I can scale up the resource. I can configure this microservices in a VM where we have higher resource, we have more resource, and I can scale up this microservice specifically. I need not scale up these other microservices to scale to give more resource to this shipping module. So we'll talk about that. How can we scale, and how can we do this kind of individual configuration for any one of the microservices? But we can do that in the case of microservices. So I can do flexible scaling, easy deployment. Yes, in the case of monolithic application, if I need to deploy even a bug fix, a small bug fix, I have to build the entire code. I have to build and deploy the entire code because it's tightly coupled. Uh, Here the codes are dependent on each other, the modules are dependent on each other. So there is a huge chance that I have been using the functions anywhere and everywhere. So even if for the small bug fixes, I have to build and deploy the entire code base. But here it's not the case. If I am fixing something in the accounts module, I just need to build and deploy the accounts microservice. Technological freedom, as I mentioned, my accounts could be in different technology. It could be in Java. My shipping could be in different language. It could be in Golang. It could be in Python. Depends on and those things. There are various advantages of microservices architecture. That's why we are moving from monolithic to microservices architecture, and you have been hearing this about this. Then reusable code, yes, we can reuse. I mentioned that I need to make these guys independent. So I cannot reuse the code what I'm writing for the accounts module to any other modules, but I can reuse the code within the microservice. I can do that. Okay, so I can again still reuse the code, but I cannot reuse across the microservices. Okay, because I would like to get this microservice independent. That's what I need to make. Okay, uh, and that's what I intend to do when I'm splitting my uh, architecture from monolithic to microservices. I want to make my microservices independent of my other microservices, so that if one goes down, it will not impact the other. And in the course of doing that, I get my highly resilient environment. Uh, so that's the last advantage and the most important of it. That even if one of the microservices goes down, it will not impact my overall functionality. So let's take this example of like Uber app or this Ola app or this Swiggy app. So if one of the modules, if one of the microservices, let's say notifications, if you have booked a cab or if you ordered a food and you're expecting a notifications to be popped up, and if there is something wrong with the notifications microservice or module, still you can order the food and still you can book the cab. It will not impact the your other functionality, but it is not the case with monolithic. Even if one goes down, it will impact the other modules as well. That's the drawback with monolithic applications, and that's what we are moving from monolithic to microservices. Okay, so that's the brief knowledge. I hope everyone just understood the definition part of it. That's what I intend to convey here. I'm going to talk about these things again. Okay, it's a demo session, so I'm just going to talk about these topics briefly, but I'm going to demonstrate each and everything in using the showing you how we create microservices. We need to install. So I'm going to have like Linux instance to show you how do we create containers, how do we install a container engine. We'll be installing Docker. How do we create containers and things like that, and how do we scale up the containers? What is Docker Compose? What is Docker file? I'll talk about all these things, and it's a workshop. I'm going to do hands-on here. Okay, but it's just a brief. I'm just trying to convey this information right now. Okay, briefly. Okay, so next question comes up. Where does this microservices run? Okay, so you know this business logic. So these things, the we can host the entire code base in the app on the application server. That's fine. That's good. In the case of monolithic application, but so okay, since now we have splitted this monolithic application to microservices, where can we run this microservices? Where can we run this? So that's the next question comes, and the answer is on the containers. It's best to run microservices on the containers. What are containers? So for that, what are containers? To understand, we need to first understand the VMs first. Back in 1980s, like when we started with the software development, if you look at my slide, what we used to do, we used to host the in one simple application, few KBs and MBs application into the physical servers. That's what we used to do. One small application to the bigger box, and a lot of resource was wasted. Okay, a lot of resource. Then eventually someone identified that we are wasting a lot of resource. Why can't we split this hardware into various VMs? Suppose this hardware has 100 GB RAM and like 2 TB of hard disk, and you have this much of 100 CPU we have. So why can we split this physical server into various VMs? And then why can we use one VM to deploy my one of the servers, one of the applications? Okay, so it was a huge revolution here, and we were able to utilize the resource in a much more efficient manner, the way we used to do before. So this virtualization was the revolution at that point of time, and still we are using VMs. Okay, when I create the EC2 instance in AWS, I create a VM. EC2 instance is a VM. Still, what you see here, this is the EC2 instance I have created in AWS. So it's also a VM. So even AWS has deployed one virtualization software onto their bigger box, because this EC2 instance has few CPU, one CPU, and it has only 1 GB of RAM. That's what I have provisioned. It's T2.micro instance type. I'll talk about that. So it's just one CPU and 1 GB RAM. Okay, total 1 GB RAM I have here. And then that's we call it one EC2 instance. It's a VM basically. Okay, so we someone understood the why can we split this physical servers, and we can create multiple VMs, and then in this process I can use this physical server. Now we have VMs, multiple VMs. I can host multiple applications. Fantastic, fabulous job. But again, now what we have, suppose if I have a three-tier application, what we are doing right now, we are doing in one of the VMs we are hosting application server, in other VM we are hosting database server, and in another VM we are hosting web server. So we are using three VMs, okay, to host our three-tier application, and we can have our application up and running, right? So now with containerization, I can have three containers. Listen to me, this thing, if someone is new to this container, it's very important to understand this part. Right now I have three VMs, and I'm hosting web server, application server, and database server in each of these three VMs. Now with containers, I can have three containers, one for app server, one for web server, one for database server, and I can host this in one VM itself. One VM is only required to run three containers, and I can have my application up and running. So again, in this process, what I did, I'm able to utilize my resource in a much efficient manner. And if there is a requirement for, if if my web server needs more resource, I can use, in that case, I can use another VM to create more such containers. And if I need more resource, I can create more, such same containers on my third VM. Okay. But if I have the requirement, unnecessarily I will not use another VM to create containers. If my load and my and the resource is enough to handle my user load in production, I may not use another VM. So that I may not use another container to accommodate the extra load. Okay, so that's the containerization. This process is called virtualization, where we created the VMs, and this process is called containerization, where we created the containers. And we have a container engine, and we can only do that if we have a container engine. We need to install the container engine on top of the, like, the same thing. On the physical server, we deployed the hypervisor software, then we created the VMs. So now in each of the VMs, we have to install one container engine like Docker, and then we can create containers, and then we can create multiple containers using Docker engine, using container engine, and Docker is one of the example of container engine. So that's what it is. So in this process, I'm just trying to utilize my resource better. That's all the intention is. I'm trying to utilize my resource in a much more efficient manner. And in this process, I can save a lot of money for my organization. It's a big thing. Okay. Sunil has asked me a question. Can you please provide some more info on the OS and VM? And yes, yes, I'm coming there, Sunil. Okay. So that's the main difference. Okay. Virtualization and this containerization. So coming back to our topic here, containers. So here in the case of VM, so what you see here, it's the VM, and what you see here is what you see on the left is a three VMs. Okay, VM A, VM B, VM C. We have this physical server here, a bigger box, and then on top of that, we have installed one hypervisor, one virtualization software. And this virtualization software could be any virtualization. There are multiple options out there. VMware has softwares, and hypervisor is one of the virtualization software. So I need to install this. If I do not install this, I cannot create VMs. Okay, so I have done that, and I have created three VMs, and these three VMs is having one guest operating system. So consider this as the application server, this is the web server, this as the database server. So that's what we are working, right? And we have guest operating system required for all my VMs. On your right, what you see is only one VM, okay, only one VM. But you see three containers. And what I have done, I have installed. So this is my VM host operating system, okay. So currently I'm currently using Red Hat here, okay. I can so this is my suppose this is my VM operating system. It could be any Linux flavor operating system. So this is my VM operating system. And on top of that, I'm showing that I have installed Docker. Okay, so Docker is a container engine. You can install any other container engine as well. Once I have installed the container engine, Docker here, I can create containers. And I can have my app server, my web server, my database server hosted in only one container, in one VM with three containers. Okay. So I can have my app server in one container. I can have my web server in another container. I can have my database server in another container. And I can host these three containers in the same VM. And I can have my application up and running. So that's the basic difference. And I'll talk about that in our regular sessions and how can we create containers and how can we install Docker. And we're gonna see everything hands-on here in the workshop. Okay. We're gonna see everything here. So currently, I do not have Docker installed here. So first of all, I need to install Docker. So this is my VM, one VM, as I mentioned, it's my EC2 instance. That's my VM. So I do not have any Docker installed here right now. Docker is not. I do not have Docker installed. No container engine. So first I need to do that. Then I need to create VMs, and I can demonstrate that using Docker Compose. Once we understand its basics definition, then using Docker Compose, we can create multiple containers at the same time. In no time, it boots up in seconds. So the basic, what's the take home message from this slide is that the VMs virtualizes the hardware, underlying hardware, but the containers virtualizes the host operating system. And in the process of host operating system, so you should notice that I don't have a guest operating system here. Like in the case of VM, I just have the binaries and libraries. So these containers will use the binaries and libraries of the host operating system itself. I don't need an operating system. This is my app server, this is my web server, this is my database server, but I don't need a guest operating system as in the case of VM. That's the reason I'm able to create containers in such a less resource. In very less resource, I can spin up containers. It's a very lightweight, containers are very lightweight, and it boots up in seconds. It takes fractions of disk and memory. We will understand that, we will see that how containers are created and how it takes such a less space. We need to talk about a lot of things here. And then a lot of advantages are here: portability, resource efficiency, isolation, better performance, and scaling. We'll talk about that, and we'll talk about container engine, and we'll talk about Docker, and then container orchestration engine. So now, if we have multiple such containers, how can we orchestrate that? How can we load balance, auto scale, and all those features? How can we implement all those features using Kubernetes? I can do that, and we'll be talking mostly about EKS, Elastic Kubernetes Service here. So that's the containers for you. Okay. So we have touched base on the DevOps. We have understood the microservices. We have understood brief about the containers. What do we exactly mean by that? And let's touch base on the cloud. Do we have any questions till this point of time? Are we good till this point of time? Or we have any questions? Please let me know. I'm going to start with a brief introduction of cloud now. Okay. So I take silence that we are good and we are all understanding everything. Perfect. So I'm going to talk about the cloud now. So what do we mean by cloud? Okay. Because here from here on, I'm going to talk about cloud only for coming 3 weeks. Okay. So I'm going to make this very simple as I can. So what is cloud and what is on-prem? So why do we talk about cloud? And before cloud, what we be talking about? We're talking about on-prem environment. On-prem. What do we mean by on-prem? And what do we mean by cloud? The basic definition of it. Okay. So a resource. When I say resource, I mean the CPU, the hardware, the CPU, memory, and all those stuff. Okay. If I do not own a resource, if I own a resource, okay, let's say if I own a resource, that's the on-prem environment for me. Your company calls that it's an on-prem infrastructure. On-prem means what? They have this infrastructure in-house. They have built one data center and they have hosted, they have their infrastructure, they have the hardware deployed and they are maintained in their own data center. Okay. That's what they mean by on-prem environment. On-prem. It is within their premises. They own it. On-prem. Okay, that's the meaning of on-prem environment. When I say cloud, the resource which I do not own, I use it. I pay rent if I need to use that. The resource which I do not use, which I do not own, that is a cloud for me. Cloud, cloud service. That's the basic definition of it. So if people are, I feel I get a lot of questions. People don't know, understand the difference here. What is this on-prem and cloud? And they, if interviewer asks a very simple question, what do we exactly mean by cloud? And it's difficult for them to become to answer them, and they understand that interviewer understands. Okay, so this guy doesn't understand the basic definition. So if we are owning the hardware, if we have the data center, all the infrastructure built for me, and that's the on-prem environment. So in the on-prem environment here, you can see what all I have. Yeah, so it's like enterprise IT here. I have data centers built up. For that, I need to buy a land. I need to construct an infrastructure, cooling mechanism. A lot of it's a costly affair. Constructing and setting up a data center is a costly affair, and you have to buy the hardware. You have to buy it. Okay, you have to purchase it. You cannot sell it. Okay, okay, you have to purchase it. You have to own that. So you have to make it on of your own always. So you have to. It's a very huge costly affair. Your on-prem infrastructure. You have to set up networking, storage. You have to buy so many servers. Uh, you have to do virtualization software. You have to purchase these many virtualization softwares. You have to purchase operating system because you have to use uh, uh, okay, okay. Anand just replied that it's difficult to hear me. Is everyone can hear me well? Is it fine now? Can someone confirm that? If you guys can hear me well.
Yeah, we can hear you.
Okay, good to know. Yeah. Thank you, Anand, for your information. Yeah. Sure. Okay, much better now. Perfect. So, okay, I'll repeat this slide. Okay. So the main question is the difference between the cloud and the on-prem infrastructure. What do we mean by that? Okay. When do we call an infrastructure on-prem and when do we call an infrastructure as cloud? So when we own a hardware, when we own a resource, that is on-prem for me, on-prem for any organization. Okay. So if I am constructing my data centers, my networking, if I'm purchasing all the servers or all the storage servers, I'm purchasing virtualization softwares, I'm purchasing operating system, I'm purchasing all the databases, then I'm going to deploy my application. So that's the on-prem infrastructure, and there I'm building my application, I'm hosting my application. So that's what I mean by on-prem. I'm owning all the everything. I'm owning data center, I'm owning all the hardware, I'm owning everything here. Okay, that's the on-prem for me. When I say I'm using cloud service, so I do not own any of it. I do not own data center, I do not own any servers. No, I'm using them. I'm paying, I'm renting them. I'm using them. I'm using, so let's say I contacted AWS that I need to use few of your servers, I need to use your operating system. Currently, I am this particular resource. It's not on-prem, it's the cloud, because I'm using, I have asked Amazon to please give me one CPU, one CPU and 1 GB RAM, so that and then your Linux operating system, Red Hat here, so that, and they have all these data centers set up. But I'm just trying to leverage the resource here. So that's the cloud for me. Okay. I don't own anything. I'm just paying for what I use. Okay, so that's the cloud for me. Okay, so that's the basic definition. See, if I have to just show you, see, currently I'm having 3 servers. Okay, I have currently running. So I have logged into this particular server here. Okay, and this is my public IP, that's my private IP here. And this is the AWS console. The automation at its peak. If you have to look at the cloud console. So I leveraged AWS instance, one instance remotely in Mumbai region. I'm sitting somewhere else. This they have, AWS has their data center. They have maintained. They have the entire thing. They have the data center. They have the networking setup. They have the virtualization setup. They have the servers. They have everything. Okay. And they have set up this data center. But what we are doing, we are just leveraging, we are trying to use their servers and we are paying them. That's the cloud service for me. So that's the basic definition. If I own a hardware, if I own a resource, that's on-prem. If I do not own it, if I just use it and I pay rent for that, that's the cloud service for me. Okay. So they have various data centers. They have so many regions out there. AWS guys. I'm currently using Mumbai here. In Mumbai, they have 3 data centers. This is it, they are the regions. Okay, they are the regions. uh, Singapore, Sydney, Tokyo, Canada, Europe. In Europe, they have 6 7 places, regions, and each region has minimum of 2 AZs, 2 data centers. We'll talk about AZs once we start with the regular sessions of cloud. We'll talk about these things. What do we mean by AZ and data centers and those things. So these are the regions. Okay, and then for each region we have different data centers. So they have set it up. AWS guys, uh, uh, your Microsoft guys, we call it Azure, Google guys, they have their region, they have their data centers. What we are asking, what how we are leveraging them? We are just using their servers, and we are paying some amount for the time we use, that's it. And we don't own anything. We have to give them back if we do not. Suppose I'm a startup company. I do not have that much of capital to create my data center and then I can host my application. I cannot do that way. So I can just use those cloud services to get few resources, get my application up and running, and I can get my business going easily. Okay, so that's the biggest disadvantage of using cloud. I can set up my application in a fly and without investing so much of capital. If I have a data center, is not an simple task. Not everyone, not all the organization can create data centers. Okay, because it's a huge costly affair. Okay, so I hope you understood the basic difference of on-prem and the cloud. Now I'm going to understand, we can understand that in how many ways. So we can leverage the cloud in three ways. Okay, we have something called uh, the the first was the on-prem infrastructure. If I have the blue ones that I own here. Okay, here. Uh, Everything I am managing as a customer, I am managing because I own everything here. It's my data center. As a customer, I am managing every bit of it. But so these three, they're here, the part of the slide uh, is about the cloud. And we can leverage cloud in three ways. We have something called infrastructure as a service. We have something called as a platform as a service, and we have something called as a software as a service. So these are called service models. Okay, these are called service models. In the infrastructure as a service, your data center, networking, storage, servers, and virtualization. This is managed by the cloud service provider. They manage it. So, and I'm using these many resources, and then I'm paying for these resources. I'm paying for the operating system. I can get to select operating system and I'll pay accordingly. I can select my database and I can host my application. I get to I get to control over my security and I can deploy my application. So I have to manage these four things, but these things will be managed by the cloud service provider here. So that's the infrastructure as a service for you. They are providing the infrastructure. That's it. And we are paying for these things. We are paying for these things as well as if we are using operating system, their operating system, we have to pay accordingly. So we get the control over these things as a customer. Today I select that I contacted Amazon guys and I opted for the infrastructure as a service. So they would provide this data center, networking, storage, servers, virtualization. Fine, perfectly fine. But I can control, I have the control over these things as an infrastructure as a service. In a platform as a service, I just get to work on my application. They manage everything here. They take care of all these things. Because platform as a service is like your if I have to take the example, suppose if you are a development or testing company where you just need some platform to develop, write the code and to execute the code. You are not bothered about the underlying infrastructure at all. So you would go for platform as a service. In a software as a service, you don't get the control. You don't have the control over anything. You use software as a service like your Gmail. We use gmail.com and then we have all the mailbox and sent item. We can compose email, we can do whatever. So we software as a service is like a Gmail. We are using one Google SaaS service offering Gmail. That's the Gmail is one of the examples of SaaS. Currently I'm using Google Slides, so that's the Google slide I'm using, and I am showing up this presentation. I have just uploaded this file here, okay, and on the Google slide, and I'm just opening it in front of you guys. So I'm using Google Slide as a SaaS service. Okay, SaaS service. It's a SaaS service for me again, because I don't have control over anything. even for the application, no, I do not have any control over the Google slide. I just uploaded my file, and then I'm just displaying my file in front of you guys. For the platform as a service, you get many softwares where you can get to write the code and execute it. Like your W3 schools, if you go there, w3schools.com, you can write SQL query. Okay, and there are many other softwares you can write your Java program, your Python program, and it will get run right in real time. You are not bothered if the Java runtime environment is installed or Python runtime environment is installed or not. So those are the platform as a service examples. You just you're just concentrating on the building the application, writing the code, executing the code. So that's the platform as a service example for you. And infrastructure as a service is what most of the companies, bigger companies, use it, and they rely on for these stuff here down below till virtualization. They rely on the cloud service provider, and they pay for what they use, and they get the control over these things. So that's the service models. We have something called deployment models as well in the cloud. Okay, public cloud. Okay, we have various deployment models, like we have private cloud. If I'm offering, suppose I'm going over select, so it all depends on who all are using that service, that data center. Suppose I in a data center, AWS has many data centers, right? And it's a public cloud offering. Anyone can host their application. Even I can leverage in this Mumbai region. Currently, I'm showing up here. In this Mumbai region, I have created one instance, and I can host any of my application. I can install my web server, app server, anything. And I have the public IP. I can enable this. I can create a load balancer here, and I can expose this load balancer to the external world, and I can get my application going. So this is the AWS is the public cloud. Anyone can host their application. Okay, so that's the example of public cloud. That's the public cloud. Suppose what's the difference between a private cloud? If I get the control over the entire data center, no one else can. No other customer can host their application. That's the private cloud. Public cloud, anyone can use it. Currently, right now, you can also leverage few resource in the Mumbai region in this data center 1A. So these are the AZs, okay? These are the data centers 1A, 1A, and 1B. So this particular instance is hosted in 1A data center. This is instance in 1A, and this is in 1B. So currently, you can also use 1A, and you can host your application. That's the public cloud. Anyone can use it. But if I'm private cloud, only I get to use this data center, no one else. So there are players in the market who provides private cloud as well. AWS provides the public cloud. Okay, anyone can use it, but there are players in the market who can provide private cloud. So no one else you have to purchase the entire data center. For a region would be a security region, because you would not like your application to be hosted by some co-hosted with some other customer, right? So that could be region. There's something called hybrid cloud. You can use multiple cloud service provider. Okay, you can host your app server in one cloud service provider and your database server on-prem or any other cloud service provider. If you're using multiple cloud service providers, that's the hybrid infrastructure, I would say. Okay, so that's the difference between hybrid. And then we have something called community cloud model. Community is like, suppose if I'm a banking firm, okay, I'm an investment firm. So all the investment banking firm came together, and they have purchased the data center itself, and only they get to deploy their application. So that's the community cloud. They can create a community. You can also form a community, and then only they can deploy the application in the data center. No one else. just for the simple reason because all have the same data security and they have the same goal. They have same thing to maintain. So that's the community cloud for you. Okay. So this is a brief introduction about the cloud, the service models, and the deployment models. And we have a lot of for the SaaS, affordable, anywhere accessibility, ready to use. I can use gmail.com, Google Slides, Google Spreadsheets. We have so many options. So whatever you see here in Google, uh, uh, see, they have so many things. All are SaaS service. Google Docs, Google Sheets. If you're looking for examples, so Google Map, whatever they use, it's all SaaS service. You don't have the control over the application, the underlying infrastructure, but you can use the software. So that's the SaaS service for you. And then platform as a service, and then infrastructure as a service. So that's the brief definition about the cloud. Okay. So we have touched base on all these things today: DevOps, microservices, containers, and the cloud. And from tomorrow, we'll take up like cloud. We'll start with the cloud, and we'll understand AWS cloud in detail, and we'll first start with the account creation and account activation, then multi-factor authentication for the security regions. We'll talk about AWS cloud from tomorrow in detail. So that's all about it today. If you have any questions, feel free to ask.
Hey, Roshan.
Yes, I can hear you. Yeah.
Okay, so my name is Anand, and I am an estate in my current position. So,
Okay.
whatever you were mentioning related to cloud containers, Dockers, or Kubernetes, right?
Yeah.
Are those related to the performance thing? I mean, based, I mean, when we see at the curriculum, right?
Yes.
So you are
See,
eventually going to take us to the, eventually going to drive us to the performance with all these concepts. Is that the ultimate
yes,
goal?
wherever applicable. See, for a performance engineer, right? For a performance engineer, if you really understand the role of a performance engineer, see, if you are not sure how to work in cloud, okay, what do we mean by VPC, EC2 instance, IAM role, or how the networking works, how do we set up load balancer, how do we set up auto scaling group? If you're not sure of these things, what all storage services we have, so it's all about, first of all, the introduction about things, and then we'll understand how can we, a performance engineer can use these things. How, like for a performance engineer in the cloud, load balancing and auto scaling group is the most important topic, because that's what he'll be asked to do. He'll be asked to make sure that auto scaling my cloud, we call it cloud is elastic. What do we mean? So if when the extra load comes up, so it has to get auto scale. You need to provision these servers automatically, right, to accommodate the extra user load. So how to set it up, on what basis you can do that? So on the basis of CPU, or on the basis of alarm? So what type of alarm do you need to create? What all type of metrics you would like to see, so that you would trigger your auto scaling thing? So first of all, performance engineers need to understand about all these things, and then you need to understand how to implement these things. And yes, we'll talk about the performance part of it with all. Most of the things will be in general, because you need to understand, if someone is new to the cloud, they need to understand from the basics, and then how performance engineers would be, what is expected from a performance engineer if they're working in this cloud infrastructure. So auto scaling and load balancing is one of the important stuff. Similarly, for Kubernetes, if we do not know how to set up a Kubernetes, how to implement a Kubernetes infrastructure, you cannot do a performance tuning of that, right? So first of all, you need to understand the how do we implement that, and by Kubernetes, most of the performance issues gets resolved, because that's what this microservices is meant for. So you need to make sure the microservices is fine. You don't have any bottlenecks as such, like memory leakage with your microservices. The normal stuff you have, whatever you have in the Java performance, you call it. And then how do we get the performance benefits if you implement that in Kubernetes? Same thing for DevOps. You would be asked to do CI/CD pipeline creation. So all things are related to performance, and that's what is kept in mind while designing this course. I hope I answered the question, Anand.
Yes. So this is nothing related to Jmeter or UFT or something, right? I
Nothing,
mean,
no, not
okay,
at all. I'm not going to take any session on Jmeter. I'm not going to take any session on UFT. No.
got it.
I'm going
Thank you.
I'm going to demonstrate you how do we create CI/CD pipeline if you have a Jmeter script, and on what all parameters you need to provide to make sure that your job has run successfully, so that your pipeline gets moved to the next phase, which is called production, right? Because once performance testing is successful, what is the next step? You would like to deploy your code to production, right? So that's what we will discuss about. How do we use Jenkins? We'll talk about Jenkins here mostly. We'll talk about Docker and Kubernetes here mostly. We'll talk about AWS here mostly. So that's this entire course is. And if you have any doubts, Anand, so that's the link you should be going over there.
Oh, yes. So, so one more quick thing. So you'll be explaining this thing, these concepts from the scratch, right? If
From
I'm not wrong.
very scratch. I assume that my audience doesn't know anything. If you
Okay.
could have understood from my demonstration, I really assume that you know nothing, like, right? And that's how I took up every topic here: DevOps, microservices, containers, and cloud. And that's what I assume, that people are new to the cloud world. They do not understand microservices. They do not understand container at all. And this is they're also new to the DevOps. So these things we are taking up from very scratch. I assume that you would know few things about here, but not anything about here. So I'll be taking everything from scratch.
Okay. Yeah, that's it. Thank you.
So thank you. Yeah, feel free if you have any questions, any clarifications. Okay, sounds good. So I take silence that we are all good. And tomorrow, from tomorrow, we'll start with the cloud journey. Yeah. Thank you everyone for joining. Yeah, we'll talk tomorrow. Thank you.